Hello. Uh, so today I wanted to show how to do addition and subtraction with using this in a base 10. So you can hold this more than one way. I'll do it like this because when I first started using this, I started using it in a base 10. Um, so let's just count up and show you how the numbers work in a base 10. As you can see, there's actually 11 dots on the whole board, and you can actually represent the number 11 if you want. And I when I was going to sleep last night after I made some videos yesterday, and it hit me right when I was drifting off, like things do sometimes, that this could possibly be used in a base 12, and base 12 is, and maybe it was, I've never read anything that talked about it being used in a base 12, but the reason I say that is because with the 40 base system that I was doing videos about before, all these dots here wind up adding up to 39, and then this is 40. And then I thought, well, we have 11 dots down here, um, and so maybe this would be 12, and maybe it's meant to be used in a 12 base because 12 is actually, I think they call it dozenal. It's actually a really good base. It's better than decimal, and I'm assuming the only reason decimal's so big of a deal and everybody uses it is because we have 10 fingers, and so it's natural, but it's not necessarily the best base to use in mathematics. Um, so here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's if you're using a 10 base. And you can go 11. Now it does have, it has 11 dots in each row, but um, even if you're using it as a 10 base, if you didn't have this one here, then how would you show 1, right? So let's just go ahead and do a couple problems. We'll represent the number 7. Right? 7. It's pretty simple. And represent the number 11. We have 10. We have 1, right? Represent the number 12. 12, 13, 14, 15, 16, 17, 18, 19, 20, and you could do 21 if you wanted. But if you're going to have 20, should be that, you just move on up and put another 10 there. Anytime you have 10 or more represented here, you just move on up. If you have 2 rocks here, you just move on up, right? And that's 10. Let's do a simple problem, simple math problem. 7 plus 8, right? 5 and 2, 7 plus 5 and 3. 7 plus 8. 7 plus 8 is 15. So again, we know we have 2 rocks here. Each rock here, when there's 1 rock here, represents 5, and you're not supposed to have more than 1 rock in the square, but we have 2, which represents 10. So we're just going to take both of these and move it up here. We have 10, 3, and 2, 15. So we have our answer, 15. And that's basically how it works. Do 30, I'm sorry, 8 plus 9, right? 5, 3, and 1. First, we're going to take these out, put one up there. Okay, this is 6, so we're going to put one in the 5, right? Because we spread out. We only want one rock in each hole. And when we have 2 rocks, you remember the rule about the Fibonacci sequence. When you have 2 rocks in one place, you move one to one side and one to the other, and it represents the same amount, right? So we have 2 rocks in the 3 square, and that's going to represent 6. But if I put that here in the 5 and here in the 7, it doesn't work like that. So what we're going to do is we're going to put it over there, but we need to, we can't have 2 there. So we're going to take 1 out and just move it up there, right? So our answer is 17. Now there's one trick here is that just like with the other one we're using as a base 40, and when I say base 40, I don't know if that's really the right word mathematically for what this is. But there's no other really base that we're using, right? It's just dots and squares. So I guess you can call that a base. It determines really what these numbers represent. So anytime let's just say you want to do multiplication. So in the same way, anytime you move straight up, you've multiplied by 10, right? You move up twice, you multiplied by 100. Move up 4 times, you multiplied by 1,000. So that does make multiplication a little easier if you were going to use it in that way, but I wouldn't use it that way. I would use it as a base 40 if I was going to do multiplication and division. So let's do a couple more problems. Let's just take 50. Okay, remember how this works. You just move it up 10. Move it up one space is 10 more. So that's 10, 20, 30, 40, 50, 60, 70, 80, 90, like that. Let's take 50, take the number 70, and let's multiply 70 by 11, let's say. So to multiply 70 by 10, what are we going to do? We're just going to move it up here. So if this is 5 and this is 50, then this is 500. This is 2, this is 20, and this is 200. So we're multiplying 70 by 10, and it's 700, right? But we're multiplying it by 11, so we're going to multiply 70 by 1 more. So we just put rocks in the same place they were, right? So you have your answer. 500, 200, 50, and 20. 770. So it's pretty easy to do this sort of thing on here. It's easy to even multiply on here as long as you are not doing like let's say 728. Okay, that would make it a lot more difficult to do it this way in a base 10. So I'll show you the number 728. Okay, that would be 728. And so then if I was going to multiply 728, let's say by 10, that would be easy. And it's just like in the base 40 system, multiplying by 8 is easy. Multiplying by 40 is easy. Well, in this way, obviously multiplying by 10 is easy because I'm just going to take every rock and move it up one space, right? So we have 7,280. I guess that's the answer. It must be. Let's try multiplying 700. What was it? 728. Let's try multiplying it by 11. We already know what we need to do. So we would multiply by 10 first. We multiply every rock on here by 10, right? That would end up having 2 rocks in here because we're moving that one up, and we need to move these up, right? So we multiplied by 10. The fact that the rocks are left behind multiplies it by 1. And then these 2 rocks here, since you're not supposed to have 2 rocks in one square. When you do, you need to move up, right? Spread them out. So I'll just take those like that. You don't really have to, but it just makes it a lot cleaner and easier to do your calculations and figure out where things are if you don't have a bunch of rocks piled up on one square. So I'm assuming I did it right because it's a fairly easy problem to do. 728 times 11, right? So this is 5,000 and 2,000. So we have 7,000. 7,500, 7,800, 7,900, 7,950, 7,980, 7,900, 7,000, I'm sorry, 8,000, right? We had 8,008. So again, I didn't write it down. I was writing down my problems before I did it on the 40 base because it's harder, and so I'm just assuming that that was the answer. Okay, so let's take the same number and let's multiply it by 12. Okay, you see, multiplying by 10 is super easy. Multiplying by 11 is super easy. So let's go one number higher. Let's multiply by 12, and it's still going to be easy, but it's going to be a little harder, right? So 728. Okay, so first we're going to multiply everything by 10, just like we did last time, all right? And I'm going to spread these out. Now we have to multiply again, right? It's 728 multiplied by 11, just like we did last time. But now we need to multiply again. So what do? Well, the way they would teach you in school, the schools that teach these, is for sake of ease, let's put those back there because one of the rocks that was in there was the rock that was part of the original number that we were multiplying, right? 500, 728. So these 2 rocks, this rock and these 2 rocks were there originally. So what they would do is they would just say, okay, leave it like that. And then now again, on every place that had a rock on it, again, you have to put another rock, right? Because we've multiplied by 10 by moving every rock up. We've multiplied by 11 by having a rock where the original number was, because that's just multiplying it by 1. It's just the number itself. Now to multiply, we have to multiply it by 1 more. So we have to do 700 and 28 again. Now, again, if you're doing really big problems, I suppose it might be okay. But now we have, it takes more work now. So now we have several rocks. We have 3 rocks here. And so what we need to do, no, I hope that I get this right. I'm not going to calculate it. You can tell me if I get it wrong. We're going to spread out like we do when we have too many rocks in one row or one square. We're going to try to what do they call that? Disseminate these rocks. So because we have 2 rocks in here, we move that up. So that was 1,000 right there. So we're going to move that up. We have 2, 2, and 2. That's 6. So what we're going to do is put a 5 and a 1. And again, here we have 2 here. So that's 4. So we're going to 1 and a 3. And that 3 there, that's a 6. So we're going to do that, and that's a 5 and a 1, so that's a 6, but we have 2 there, so we just move 1 forward, take that out of there, and we do the same thing here. Take these 2 out, put that 1 up there, that's 10. We have 6 here. We're going to spread these out, and oops, I didn't see that, so we do the same thing there and spread those out. We have 2 there, so we move that up, and so I hope my answer is right. It could be wrong. If I'm wrong, whatever. I made a mistake, but it should have been an easy problem. 728 times 12. So whether it's right or not, my answer would be 5,000, 2,000, and 1,000. It would be 8,000. We could have taken these and put them there, but whatever. So it would be 5 and then 3. So 8,000. 8,500, 8,200. So we got 8,700, 8,720, 8,730, 8,736. I don't know if that's right or not. I don't really want to calculate it because I'm afraid it's wrong and I made a mistake. But anyway, you get the basic idea of how it would work like that. Okay, let's do something that I talked about doing in one of the videos before. If you get your answer right, you get a piece of candy. Actually, I probably just end up eating it myself. But yeah, if I get it right, I get a piece of candy. How's that? So I don't know because, again, there's just no way to know. But my suspicion is that this kind of way of doing things, this mathematical process here, is pretty natural. I think that the modern school systems nowadays intentionally dumb people down. They dumb kids down. I don't know, maybe I'm too much of a conspiracy theorist, but I think it's pretty obvious. And so when you find a culture that's less advanced, you'll actually supposedly less advanced, right? You'll actually find that they have ways of doing things that are more advanced in a way. And advanced isn't the right word, but more organic, more holistic. It's better ways of doing things. And that's kind of what I think about this. They don't really teach it in schools, and when they do, they teach it wrong. And it just doesn't make sense to me when you're a government of a nation, and without you have all the resources that governments have of nations, and governments seem to be able to do almost anything they want when they want to do it bad enough, and then they teach kids how to do stuff completely wrong, famously with mathematics. It's like that with everything, right? So I don't know, but this is what I discovered, is that you can take this section off of there and use this as a base 15. and I didn't really come up with this. I heard there's a theory. One of the theories about the Upana is that you can use it in a base 15. So I don't know if you're using this column as well, how you can use it as a base 15. I haven't really read it that much, but if you do this, you can. And it seems a little easier to me to do problems, even though you can't go quite as high. You can't go up into the hundreds of the thousands, I don't think. But let's see what you can do. So again, this is going to work the same way that the 40 base system did, but I'm just going to keep it like this. Instead of turning it that way, just keep it like this. And I don't know. So if you're going to represent a number on here, how high can we go? 1, 2, and 2, 3, 3, and 3, right? We got 9, we got 4, and we got 5. So we got 14. So it's going to work the same way. So let's just say we'll do it first to where each dot is not marked with its own sequential value, but each dot simply has a quantity value instead of a sequential value, right? Instead of being 1, 2, 4, 3, 6, 9, it would just be that's a 1, that's a 2, that's a 2, that's a 3, that's a 3, that's a 3. And there's no sequential value. There's no particular value that each one has. So again, it would just work the same way. Let's say I have, that would be the number 4. So I want to multiply 4 by, let's just say 6. 6 times 4. Right, 6 times 4 is 24. Okay, so where would 24 be on here? This goes up to 15. I haven't done a problem like this, so I'm just doing it right now. It's the first time.